Yeah, so I think there's a lot to be said about that. There's to use these laptops that might have been recycled, even if the battery doesn't work. If you've got them hooked up full time, and like you said, take 3 or 4 of those, tape them together. People in like war zones, for instance, I know that there's a big push for having mobile data centers, things that you can drive around in vehicles, right?
Mm-hmm.
Like you said, take 4 or 5 of these things, stick them in the back of a car. They can hit the Skylink uplink to transmit data off of it and keep none of it local, right? Just make sure it's always ephemeral.
Yeah, and I happen to think even for environmental reasons, if you can get some use out of something that would otherwise end up in a landfill, you're sort of helping out the planet a bit rather than helping bid up the price of Raspberry Pis while the supplies are a little short.
Yeah, you just need to be careful about not angering your significant other with the quantity of old computers you're gathering, I guess.
Yeah. And I don't know that I'd recommend, for a production scenario for a Fortune 500 company that you base your systems on cobbled together used laptops. But hey, all of us, I think, are in this situation where one of the things that we promoted in this whole home lab, Birds of a Feather, is that when do you get a chance to learn things, play around to the point where you might break stuff on the production systems? Having kind of this home lab to play around with or experiment with, or even as a developer, lets you have a learning environment where you can make mistakes without the repercussions of doing that on production systems. And I don't know, it almost, to me, brings back the joy of being a kid again, where you can go in there and play with your toys and knock them down and start over again a little easier than the production systems.
Yeah, I know what he means about significant others complaining about it. Now we had to go out specifically to Michael's to get a chest of drawers that could satisfy my need to keep all this stuff organized. I couldn't keep it organized in boxes, closed in behind a closet. I couldn't find things. I couldn't find the cables I needed. Very frustrating. So now things are a bit more organized. So yeah, I know what you mean about holding on to things. I've often found myself tempted to throw something in the bin and had said, go back in there and dig it out later on. Like, I think I could use that again.
So Tomoya, you joined late, but just to let you know that we didn't have any items on the official agenda, but we've gone into Birds of a Feather mode and people are just having a chat of things they want to talk about or stories of things they've discovered recently. So if you've got anything in those categories, you're welcome to put them on the table, as is anybody else here on this call.
Might I add, there's a very nice, I don't know if it's a proprietary stuff, but there's a company called Edge Impulse that does a lot of nice things for you when it comes to audio and machine learning on the edge. And from what I understand, they do have certain SDKs which can run on Arduino Potentas or Arduino Nanos. So it's that well optimized. And I haven't had the opportunity to play with it, but they have some nice tutorials where you can already test your data with some predetermined data sets that they have or some training models that they already have. So might as well, it's worth checking it out.
What was it called again?
It's called Edge Impulse. I'll put a link in the chat.
That little brick ML is interesting.
Yeah, what I do know of is actually, as far as I recall, it's also one of the main directors of this company is the person who designed CoAP, Zach Shelby.
Oh.
So yeah, so it's quite a nice thing. I haven't had the opportunity to try it, but it's very well documented, and there's a lot of activities that people tend to do in this particular thing, and it's also open source, so it's not like it's completely closed off. But yeah, I think certain aspects of it will, for example, your remote management and everything happens through their cloud systems, but beyond that, I think it's quite well designed in that sense.
I'll have to take a look at it. I threw out another one on the chat that I became aware of unfortunately, I don't believe it is open source, but it's CNCML. And the context where I became aware of this is that one of these embedded system chip vendors has done some workshops demonstrating this. And this is in that category of predictive or preventative machine maintenance, where this CNCML can hook up to audio or ultrasound sensors and anticipate, based on machine learning, it can monitor machinery for health and preemptive identification of potential problems. And looking at their website anyway, it looks like, you know, it has extended pretty far. But like I say, this is, I think, one of the biggest opportunities in Edge. Yeah, the whole world is talking about things kind of in user interface and search replacement with ChatGPT. But I think when it comes to machine learning and AI, there's a lot of opportunity related to Edge that isn't interactive, but hooked up directly to sensors to, you know, almost take a bite at the data streams before the humans get involved, to make the humans more efficient. So you're not looking at mundane things and those kind of jobs where they say, I don't know, airline pilots, for the most part, you hope it's a boring job with nothing to do, but you train for those events. And some of these things aren't going to be susceptible to the boredom and monotony of these data streams. And they can probably digest the data in massively higher volumes and react quicker than humans can, and leave the humans to the actual detected events after they've been pre-processed. But yeah, anyway, the CNCML appears to be available for popular platforms, but I do believe that it's licensed and not open source, or that was sort of my determination as I was poking around with it. It's kind of interesting because I suspect that there might be 2 or 3 more of these, and there's probably more to come. And maybe this is a unaddressed niche for open source. Frederick, as being with the Eclipse Foundation, where you host a lot of these Edge projects, are you aware of any that fall in this category, in kind of in the Eclipse stables that would do ML for Edge?
We have some of our projects that will integrate third-party frameworks and things like that, but I don't think we have anything, you know, strictly focused on that particular use case. So, for example, Eclipse Cora, which is a popular solution for gateway, can run containers and has tight integration now with the NVIDIA AI stack. So they had a talk at EclipseCon describing the whole workflow, and it was quite interesting. I can fish out once I'm done speaking the actual link to the video if you want, Steve, for that particular presentation.
Sure, that sounds interesting.
Yeah, and apart from that, and I know that they have on their roadmap that they will add support for other AI stacks like PyTorch and others, so that it's easier to work. Other than that, of course, you know, our general purpose Edge platforms like Eclipse.io Fog can run AI workloads, but I don't think the team has put together any specific guidance to run it. You're on your own to package your containers and things like that. Although, as you know, the team at EdgeWorks has been working on putting together AI-powered cameras and things like that. So maybe if you are nice and ask on their Slack, they will they will give you some pointers on how best leverage it for your things. That's about what I can think. We have something called Deep Learning 4J at Eclipse as well, but this is really a Java type of framework, so probably less popular with this particular crowd here.
Yeah, I think kind of it's just like even at the larger scale, the Kubernetes orchestrator anything that can host apps could host an app that's in the ML category. But, you know, I think there's an opportunity here for things to provide kind of the framework or library.
Of course.
Specifically made for this use case of both. I think even putting together the training and the ML is big. So some of these, they've already pre-trained a model and the project is delivering the model. But others are more generic where they'd help you build your own for some specialized use case. And I think there's probably some already out there and more to come. I dropped another one in the chat, this tiny ML, and yeah, I'm aware it exists, but I haven't had any time to go look into it. But yet another one that is out there and appears to at least have some people who have applied it on some hardware for edge applications.
Yeah, it's a fairly popular one. I'm aware that a few of our community members used it specifically. And at our IoT Day in Grenoble, we had someone speaking about how they leverage that very quickly to put together a solution.
I did notice another one that ended up on our list of open source for Edge too, that had a special, it sounds like it was originally developed to be navigation for autonomous drones, you know, where you might give it GPS coordinates that the drone is to fly to, and maybe even a multi-step path where it flies some, you know, to 4 waypoints and then returns home. And I believe some of these are popular for drone filming, where you'd send it on a known path to do reconnaissance or even filming for the purposes of making a movie. You know, that a lot of these movies have drone shots now, and you could have it fully remote controlled, but if it's to go over a path of a mile and you know, the waypoint mechanism maybe is a better way to do it. And
yeah, I've seen them using this for things like auto racing and bike racing, you know, the e-leagues and those sorts of things, where they've pre-programmed the drone to go all over the track and then just pick up that feed whenever they want.
But it was interesting when I read the project docs, just to put it in our spreadsheet of open source, it said it now supports cars, submarines, boats, and basically it had a list of anything that walked, drove, or crawled. And it really sounded interesting. You know, one of the fascinating things, just dreaming here, is what if you had a car racing circuit where you took out the human drivers, and maybe you could do things that are impossible to do with humans just because it's too dangerous or too much G-force. But I don't know. I, for one, might watch it.
You've seen the DRL, right? The drone racing leagues?
Yeah, I have.
Yeah. Pretty wild.
I don't think the one I saw was driver controlled, though, with what they call first person video, where they put in, you know, goggles, a pair of goggles. And I don't see why, because the track doesn't move around, other than avoiding collisions, why you couldn't turn that fully autonomous. And frankly, even in collision avoidance, if some kind of ML got the camera feed, it might actually be better at avoiding collisions than the humans are anyway.
Yeah,
and
exactly.
At least in the race I watched, the humans weren't very good at avoiding collisions. And, you know, maybe that was part of the entertainment, because some of the part of the design of the field seemed to me to be designed to kind of actually create these choke points that are going to lead to interference problems with spectacular crashes.
Isn't that one of the
not having a crash, right?
Yeah. Isn't that one of those projects from Eclipse Foundation, if I remember correctly? It's from, I think, Angelo, the Zeno project. Correct me if I'm wrong, Frederick, right? They also have this form of, they have this protocol, which apparently they've used it in this IndyCar autonomous racing systems or something. I haven't had the chance to deep dive into the protocol, but I think it's supported by the Eclipse Foundation.
That's
Yeah,
Cyclone
you,
EDS.
well, that's the thing. Both Cyclone DDS and Zeno have been involved in the challenge. But you are correct, Sean. They were encapsulating DDS traffic in Zeno because DDS doesn't like to hop from one network type to another. So that's how they relate telemetry and commands to the cars. And you know what you just described, Steve, makes me think about a project that's the latest one we welcomed in our working group, the IoT one at Eclipse, and it's called the Athanis. It's not a way to run AI on drones or anything like that, but it's a way to offload complex mathematical calculations in real time. So it could be used, of course, to implement a higher end AI framework, and then you push, to a edge server, the hard number crunching and get back the results. And it seems they are working on a hardware accelerator at the company that submitted the project to us that will complement the software, but you can use the software platform. It's open source without the actual hardware.
Just one question to the community over here, if I may. I am part of, professionally, I am into industrial automation stuff. So of course I am into edge computing and per se, but I wanted to ask the community about one particular thing that I think is a bit like, for me as someone who's working with edge devices, because we at Emerson do generate our own hardware, and we do ship them with specific software. There's this one huge quantum leap that I always see when it comes to like using containerized solutions on the edge. And that thing is, most of the times complex standalone stacks can be, let's say, can be created through tools like Docker Compose, right? But what I do feel is like once you have to jump to tools like Kubernetes with orchestration, that's a huge quantum leap for a couple of our applications or something. Is there some middle ground from your experiences that you know of certain tools that can somehow, let's say, bridge a gap between starting off from Docker Compose and then not having to do this huge leap towards Kubernetes? Because as far as I understand, for me, I can understand Kubernetes, but for industrial engineers who have, let's say, 20 years under their belt, IT tools are becoming extremely complicated. So for them, even reading a complex YAML file is something like tearing the hair off their head sometimes, right? So I was wondering if the community actually has some ideas regarding how do you bridge this gray area.
I'm going to sort of laugh because I think you just filled in the rest of our remaining time in this meeting. There not only are such tools, there's so many of them. I don't even think we can even cover them before the meeting's over.
I see.
And different attitudes. And, there's a couple different approaches I think that are popular. One is, you say Kubernetes is too complex, and, there's many aspects of that. It is complex, but you can put a layer on it to where you run an application program that does the Kubernetes parts for you so that you have a framework where you're running on top of it. There are also attempts that I would say describe as modified Kubernetes, that make it thinner or more appropriate for edge. And then there are some others that aren't Kubernetes at all, and are alternate orchestrators that just happen to use a Docker engine or a Docker runtime. Even with regard to Compose, you could potentially still use it, but cover it up. And I would say that a tool like Portainer could remote manage unattended nodes that actually are using Compose, or at least Compose YAML, even if literally Compose isn't there, to manage the workloads at edge. And cutting edge things like WebAssembly are out there, alternate orchestrators. Some contend that Nomad is better than Kubernetes, and some of these become religious discussions. So I'll just throw out that general thing out there and open it up to others, because I think maybe half the people on this call have some opinion or experience here. So
Yeah, our experience has been in this space is that, and I see this a lot too. I mean, even in engineering, you don't get oodles and oodles of people in the population that understand distributed systems or want to work in that area, right? Data science, as popular as it is now, and low code, no code, begs the question, why should I have to learn other tooling in order to do the job that I need to do, right? I just want to get it done. I just want whatever I'm working on to be distributed, and I want status, and I want data. So I think, what I've seen probably along the same lines as what Steve has seen is in certain spaces, especially in the CNCF, is there's a concerted effort to build abstractions on top of tools like Kubernetes, for instance. One of the more popular ones is what we've experimented with here is Argo CD, right? And it's the idea of trying to dull the edges of Kubernetes so you don't get hurt. And it makes it a little bit more attractive and easier to build deployments that you can send out. So I would say that, it depends on what area you're coming from. If it's the area of GitOps, CI/CD, continuous stuff, then I think that area is pretty well maintained. It's got a couple of different options, but then you move into other spaces where it's not so readily available, but it's burgeoning and it's starting to take off in areas like observability, right? So it's more on the ops side of things. But there are tools out there, but once you get to that level of abstraction, what you start to lose is their ability to work with each other again, right? Unless their objects are aware of each other, or if they make a concerted effort to integrate with each other, then you start to lose that at that abstract layer. But there's a lot of these types of abstractions that are out there. You've got to find one that kind of fits your domain expertise and the ontology of the domain where you operate.
I think Andy's comment about domain expertise is a key part of this, because we're talking about industrial engineers that are experts in their domain. And then as soon as they get into this Kubernetes space, they're starting to look at the entire cluster as a system, like Andy was referring to. And they're starting to look at all of the technologies that make the stack vertically, but they're also starting to look into all the horizontal processes like GitOps, CI/CD, and DevSecOps that they need to learn about in order to deploy to these systems. And I think therein lies the challenge. We have a tendency as engineers to throw people in the deep end and tell them they have to set up their own Kubernetes cluster as the first step. But where a lot of people have had success is leveraging existing managed Kubernetes services like the cloud service providers offer. And I think that might help these people adopt these newer cloud technologies by allowing them to focus on specific areas, to work in adjacent domains. So the industrial engineer may not have to worry about setting up a Kubernetes cluster and instead figure out, okay, how do I take my industrial application, package it, and deploy it, and start there.
Yeah, I think,
go
ahead.
Steve, go ahead.
Oh, I was going to make the observation that I think if we look over into kind of the data analytics realm, that I would contend things like Jupyter Notebooks were a tool intended to help a data analytics person who just wants to make observations, conclusions, predictions from a pool of data easy without getting down into being a hardcore programmer, and learning programming languages in detail. That was a very successful project that's used by a lot of researchers. And perhaps in this edge community, whether it be applications like control or just data analytics again, there's a real opportunity for these kinds of tools that allow people to not get into the details. Even in classic industrial engineering or industrial control, I would say that things that were out in the 80s, like PLCs or programmable controllers, were a wrapper that gave people who were more or less closer to the electrician training capability realm the ability to do things without learning to be an embedded system programmer. And, ultimately what was going on with those early PLCs was even getting down into machine language to make the the control loops operate at very low latencies, very predictably, but they put the wrapper of things like PLC ladder logic and things up there to bring it up into an abstraction that people were already comfortable with from day one. And those attempts have always been pretty successful.
Yeah, if you've seen anything that's, it's not an open source project, but is it okay if I mention it here? Modal.com, MODAL.com. And this is inspiring because what it allows you to do is it meets the developer, the engineer, where they are, and almost in the case, no matter which domain they're coming from. If you could think about, let's say, writing some Go code, and in that code, you dispatch something to take place, an action, a function. When that gets dispatched, imagine the infrastructure and the platform underneath it being provisioned automatically without you having to do anything. And this is, I think they're starting to close that gap with Modal, and a couple of other, like Ray even goes a little bit further down that. I think that's more open source. So Ray, I think, has that same capacity to be able to say, well, you know, I need to burst or run a number of these threads simultaneously, and it goes ahead and figures out where it's going to run things, and you don't have to. So meeting the developer, the engineer, or the data scientist where they are is, I think I agree completely with Steve. There's a lot of fertile ground here for doing work in the open source to bridge that gap.
Yeah, and even though it's closed source, yeah, certainly bring it out, because a lot of open source projects come about because people are attempting to emulate or clone something that is out there in the closed source world, and maybe, you know, is lacking in features or viewed as high in pricing and costing.
Yeah.
So
I think you're going to see a lot more of this too with the advent of ChatGPT, because people want to run just about, you know, want to execute things based on conversation now. And so very good possibility that you'll find, I think, things like ChatGPT influencing other APIs to be ready to take instruction and to build out and provision things on your behalf without you knowing, you know, the particulars of how it's being done.
Yeah, I think that makes sense. However, like it's quite interesting to observe. I've been observing this pattern quite a lot, at least in the industrial automation space. There's a big boom, as Andy mentioned, about low code or no code logic. So things like tools like Node-RED, right? That's a massive thing. It gets served by almost all the biggest industrial automation providers, because it just makes it easier for a control engineer to just create some flows, get some data out of what Steve was mentioning, right? Abstraction over abstraction over abstraction. So assembly code to C to ladder logic to OPC UA, that data gets generated, and then it gets picked up upstream, and then people tend to do a lot of things for that. So yeah, it makes sense. But yeah, I was just trying to figure out if there's a gray area between someone who's working with simpler, let's term the YAML files from Compose a bit simpler in comparison to Kubernetes. And it is. I think I personally believe there's still a bit of gray area there, where you know, things like if you take Docker Compose itself as a tool, right? It doesn't provide you the power of a Helm chart. It doesn't let you do templating on the fly. So you can't specify, at least for orchestration tools, it becomes very difficult when a customer, or at least even an engineer, wants to say that, guess what, I want to deploy this particular container on this device because this container is connected, let's say, to a physical entity on that edge device. Whereas an orchestrator, from my personal understanding, I think it more or less, if you don't specify certain node IDs or something like that, the orchestrator will try to find the best optimum solution out, and it'll try to deploy it within that cluster, right? But a lot of times I've observed that it's mostly the case that a lot of requirements in industrial automation at this point of time is just one-to-one mapping with the physical device itself, which at certain point of time, I feel like Kubernetes might be an overkill, of course, but I mean, of course, with different filtering logic and some tags and everything, you can achieve that kind of things. But yeah, it's quite it's an interesting observation that I've been currently trying to look into as well as try to solve. Right, so everybody wants a time series database on each and every device that they have, so that they could have a nice dashboard to show the management perspective, to show the management personnel how things are working. So that's unfortunately the case where they won't accept a lot of high level tooling like orchestrators like Nomad or Kubernetes, because for them, they also are concerned about the fact that if things go down really bad, troubleshooting a Kubernetes cluster might be extremely difficult for them on the longer run.
Shannon, I dropped a link in the chat. It was a demo day that we did for KCP Edge a while back, where we showed an OpenAI GPT model to modifying, manipulating a YAML declaration for config for 7 different, it's heterogeneous Raspberry Pis, let's just say. They were each outfitted with either a sense hat, not a sense hat, a camera, not a camera, or they were in a region or not in a region. So you have to change things like date and time considerations, functionality, capabilities, so that the pods don't fall over, right? Because you've tried to address a camera when the camera doesn't exist. So you're talking about it as a one-to-one relationship. I'm talking about the cardinality as in million to one. How do I get a million different objects or different heterogeneous configurations to deploy without having to go in there by hand and change the configuration? And so that's definitely something we're researching. We don't want people doing that by hand, but you're right. Like, you have to have the coupling of the observability that also takes into account that the person didn't deploy that platform and probably doesn't even know how to spell the term, how to spell Kubernetes, right?
That's absolutely
you got a really
correct.
good point.
Yeah. So just back to the point, I think, Andy, you're absolutely right. I completely agree with it. I was just trying to play around with this concept of if I were to add some templating logic to my Docker Compose applications, right? How would I go around doing it? So I just recently started working on this repo of mine, which is completely open source. And I just recently found out that Frederick might be, there's still open places for the virtual Eclipse virtual IoT day. So I probably might give a talk about it, but it's just it's the same logic as Andy was mentioning, right? An abstraction layer over your Docker Compose file. So all you have to do is take care of 2 files and it'll do the rest for you. And I just recently found out that you can use a Docker Compose command on your, let's say, host machine, and tell the command to execute the whole stack on a remote machine too. So, which is quite interesting. It tends to solve a lot of problems. However, like I said, there are, of course, certain drawbacks and trade-offs that you have to consider on the longer run. So I was able to actually achieve this kind of thing through a nice combination of Ansible and Docker Compose itself. So I think, I don't know if it might be interesting for people who work with containers every day.
That does sound interesting. I will point out that, there's the logistics of just writing the Docker Compose, which, the demo Andy's talking about, I think I watched that and it was really cool. But there's a bigger picture. A lot of people make the mistake of doing a proof of a concept and they get one of them working by tuning it by hand.
Right.
But what they don't think of, they remember the effort of how hard it was to do their compose file and get it to work. But the bigger picture is doing this at scale with things like policy enforcement, so people don't make security mistakes, keeping audit trails, because unfortunately hackers are out there in these edge locations being unattended with no physical security, are going to be targets, and they historically have been. So it's not if it's going to happen, it's just how often. You need the ability to do rollbacks because mistakes happen, human error or whatever.
Absolutely.
So, I think that people have had a lot of success using this GitOps paradigm where you basically, just like Git has a reversible audit trail of what changes were made to source. If you put kind of your configuration and infrastructure settings in a Git repository and do that in a way that you can operate it at scale, that, like I say, a number of people have been successful at that. Maybe people will come up with even better ideas, but what goes on in these things is bigger than just the YAML for one app at a time. I think kind of the looking ahead 2 or 3 moves on the chessboard, you got to look at observability and tracing. And I don't think you'll ever, if you're operating 100,000 nodes, even 10,000, certainly a million, you'll never get away with the need for experts who understand all these abstraction layers. The abstraction layers will be a force multiplier for people who don't want to go drill down into the deep dive details. But sooner or later, you run into a tough to diagnose root cause analysis problem where, people are reporting this thing just is running slow. And if you've got n abstraction layers, I've been around long enough with enough scar tissue that I think you always need that backstop of either one person or a team of people who can go in there and get together in a room, whether it's physical or Zoom, and be able to drill down to analyze what's really going on. And to enable that, you need things like logs, tracing data, classic observability, and you kind of need to put that in place from the get-go, not when you have this horrible problem and you retroactively wish you had this instrumentation that you didn't think of at the beginning.
Yeah, this notion of day 2 existing while day 1 is being worked on is, I think, is a great idea. Not many people follow it, but we're trying to bring those ideas together. But as I was saying to Shan earlier, is sometimes you might even be able to fix the problem on your own, right? But you can't explain it necessarily in a way that, you're talking about a Kubernetes deployment or a pod or a container has failed. You have to give it in more of a terminology that is in the native language. So there's that also to be considered, natural language.
Absolutely.
It actually will. Well, go ahead, Shan.
Yeah, just just as a funny side note is like the best way to solve such kind of problems is just hire more IT people, right?
That's how we keep this in business.
Yeah, this is probably a great opportunity too on just monitoring this infrastructure to use AI ML, kind of eat our own dog food in this industry too, because you've got these AI MLs doing things like, I don't know, like I brought up that CNCF that listens for problems in machinery. There's no reason this shouldn't be the AI's MLs, and some of them have been out there for years to varying degrees, but they could be improved. Watching the logs, watching the observability, the tracing, the time series databases for issues even related to our own IT infrastructure and deployment of apps out to edge locations. Sometimes we deliver the mission just for this specific use case, but internal to our own systems, I think there's a real opportunity to utilize this same kind of mushrooming of AI capabilities in the open source.
Yeah, I think I agree, but there's one caveat to, I think, the AI ML talks is the case that predictive maintenance for one person might be absolutely different in terms of context for someone else, right? Like, I mean, we get it. It's a you try to predict all this and that, but like, for example, the data sets, the ontology behind it, the naming structures or the schemas or something might vary drastically between just two entities of the same huge enterprise or corporation. So I think generic tools are definitely helping there, but I think let's say one silver bullet to target predictive maintenance for a lot of industrial automation stuff, at least from my perspective, is still not there. I think it might over the time have that kind of feature and enablement, so where you can say, okay, I have this and that, this kind of structure, hence I want this to be my maintenance algorithm or something like that. But yeah, currently I do see a trend that it's quite it's quite distinguished, distinct, and quite different for a lot of users or people who are at least trying to come from the operations technology to the IT technology. It's a huge gap sometimes that you observe on the longer run.
I've learned a lot today. Thank you.
Before we run out of time, one last thing I wanted to throw out, and maybe there's more if other people have other items, but the Kubernetes on the Edge Day is coming up in Europe, in Amsterdam, in about a month. They just posted the schedule. I put a link in the chat. It rolled off, so I put it in the chat about 15 minutes ago. Unfortunately, the event is already sold out, and maybe this is a testament to how hot the Edge topic is, but the event actually sold out before the schedule of what the talks was posted.
Wow.
So, you know, they need a bigger facility or room, I guess, but it will be there. And if anybody was headed to KubeCon, I will be there. So track me down and let's maybe have some kind of face-to-face physical meeting of the people who are active in Kubernetes on the edge space.
We're going to be having some telepresence there for that one. We were too late to submit. And so I won't be able to meet you at this one, but I definitely will be in Chicago at the end of the year. I'd
Okay.
like to meet up.
And actually, I think there is a Red Hat / IBM speaker on the agenda, if I'm not mistaken. So there's at least somebody there.
Yeah, we're doing a portal at the booth, I think. So I think we've got 2 slots open, maybe 10, 11 minutes each. I'm working on trying to lock that down now.
Mm-hmm.
But yeah, looking forward to meet you in person when we can.
Where are you based, Andy? Just out of curiosity.
I'm in Stanford, Connecticut, and I work
Okay.
out of our Yorktown Ossining Research Center, New York. Where
Okay.
are you out of, Steve?
Los Angeles, so opposite coast. Otherwise, if you were here, I'd say, you know, maybe we can have a meeting at a physical meetup. We're trying to bring back the physical Kubernetes meetup groups that were operating monthly in Los Angeles and got killed by COVID. But we've had recent discussions to start that series up again. Here in LA, they were drawing a couple hundred people a month back at the peak. And I'm sure Boston is big enough to possibly have supported something like that as well.
Yeah, that would be great. I'd love to see that come back.
Yeah, right now, I think the one in Chicago, they have announced that there will be a Kubernetes on the Edge Day event, but I don't know that it's even open for CFPs yet. I think they typically don't do it until the other one has happened. So
okay, yeah, I haven't seen it yet either. I've been paying attention to that. Yeah.
Not until first week of November, so I think there's probably plenty of runway left on that. Yeah, we've got an entry and we're accepted to GitOpsCon. We're going to do a talk on. So I guess I'll plug that here. We're going to do a show in a lightning talk how we've experimented with Argo CD at scale and where the bottlenecks are, and we're also working with the Argo CD folks to fix those and work on benchmarking. We've got an entry into PlatformCon, but we didn't get accepted, so we'll just have an honorable mention there. And then we have KubeCon at the end of the year, and then we'll do some EU stuff. But yeah, so whenever there's another opportunity to get together, we'd love to do that. Okay, so we've reached the top of the hour, and some people already in the chat indicated they have to run. So let's close this. So thanks everybody for coming. I think there is an agenda item for the next meeting that's in a couple weeks. So maybe it'll be a little more structured, but thanks for coming and we'll see you then. Bye.